Hello guys, welcome to another episode of Rad Science. So welcome to the Rad Science Christmas special, and I'm proud to announce that as of today we will be having a studio audience. Okay, so today on Rad Science we are going to be talking about populations and their growth patterns. What are populations, you ask? Populations are all the individuals of a species in a given area. Okay, so let's say we're in the North Pole, right? And there's just a bunch of, reindeer, walking around and stuff. That's what a population is. That number of reindeer in the North Pole, in that little area of the North Pole, that's a population. Okay, so now let's talk about size changes in a population. So changes in a population size are determined by immigration, moving in, births, immigration, moving out, and death. So now that we've talked about the things that change the size of a population, let's talk about the different population growth patterns. There is exponential growth. That's where there's a J-shaped curve if you're on a graph, and it'd be, they're kind of doing all right, and then they shoot up, like the reindeer population, they're prospering right up here, and then obviously eventually they're going to hit something called carrying capacity. Now, what is carrying capacity? Carrying capacity is the amount of a population that a space can uphold. Now, the amount of a population that a space can uphold can depend on different things, such as like the amount of food there, the amount of water, and the amount of space, which are things known as limiting factors. So now let's talk about the other population growth pattern, which is logistic growth. It's where, the reindeer population, once again, they're like, they're doing okay. Then they start to kind of rise up again, like in exponential growth. But then, like, as they kind of rise up, as they get close to that carrying capacity, they're like, oh crap, we gotta, kind of curve off again, and we gotta just kind of stop growing. So that's what logistic growth is. Okay, so now let's go back and talk a little bit more about limiting factors. There are two types of limiting factors. There are density-dependent limiting factors and density-independent limiting factors. So density-dependent limiting factors are when the limiting factor, it depends on the density of the population. Like, for instance, if there was a big population, a density-dependent limiting factor such as disease would affect the population a lot more, as if it was a smaller population, disease wouldn't really affect more, because if it's a smaller population in that space, then there's a lot more space in between, those reindeer roaming around in the North Pole, compared to if there were a lot of reindeer in the North Pole in that little space, then disease would spread a lot quicker and would spread a lot more among those reindeer. And there are other density-dependent limiting factors, such as competition. If there's like another species in that given area competing for the food that's in the area, like let's say there's elves living in the North Pole with those reindeer, and they happen to both eat, magical reindeer seeds, then obviously there's going to be competition, and that will also would depend on the density of the population of reindeer. Okay, so now let's talk about the other limiting factor, density independent limiting factors, which can involve things such as weather and natural disasters. So let's, for instance, let's go back and refer to a great event in history that happened the great snowstorm during the Rudolph times. Obviously, that was going to come through the North Pole. No matter what the population size was in the North Pole, that still came through no matter what, and it still caused destruction. Obviously on Christmas, I know my mom was very mad that year when she didn't get her presents exactly on time due to the humongous snowstorm that occurred in the North Pole. But once again, density independent limiting factors aren't just natural disasters and weather. It can also be human activities. Like, let's say Santa Claus one year, you know, the latest model of the sleigh came out and it flies on its own without reindeer, so he doesn't really need reindeer anymore. So let's say he just goes on you know, a killing spree with the reindeer. He decides he doesn't need them taking up space anymore because he can build you know, a bigger workshop up there in the North Pole. So he just starts poisoning the magical reindeer seeds and killing the reindeer. That's like a human activity that you know, would affect reindeer. But Santa Claus, you know, he doesn't just have to poison. Can we keep calm with the rubber ducks, please? Okay. So let's say he didn't poison the magical reindeer seeds. Like, he just continued to build his workshop without killing the reindeer. Obviously that would take up the space that the reindeer needed to live in, and that would kill off some reindeer anyway. Okay, well, that concludes today's lesson on population for this episode. And now I'm very happy to announce that we have a special guest here with us today. Please welcome Trans-Siberian Orchestra playing Wizards of Winter. So give it up for Trans-Siberian Orchestra. pretty radical. So that concludes today's episode of Rad Science. So tune in next week for more radical and awesome science.